we have the nth root of a number. The nth root of a number. Now, we are all familiar with square roots. So let's look at square root again. Square root. Square and then root. The opposite of square is the square root. So if you are not going to look for 4 square, then it means you are going to look for the opposite of 4. And that will be the square root of 4, and then you are going to have 2. 2 raised to the power 2 is 4. The square root of 4 is also 2. No, so where from this nth root? In math, we have so many roots. The most popular that you get to know at this level is the square root. But today we are going to introduce you to other roots. Now, square root means that where the n here is written is supposed to be 2. So this and this are equal. The 2 here means it's a square root. They don't write it. There's a 2 there. So this is a simple way to write it. But these 2 are the same. So it means if it's not a square root and it's a different root, the number should clearly be written. For example, if it's a cubic root, so whenever you see 3 here, the name is no more going to be a square root. It's going to be a cube root or a cubic root. We have 4th root. It can go on and on and on. Now, what does it mean when we have the nth root of a number? Now remember, any number can be written as a fraction with a denominator of 1. So I'm trying to write the n as a fraction. So it's going to be n out of 1. The square root or the nth root of a number is the same as the number raised to the power the reciprocal of n. And the reciprocal of n is 1 out of n. And this is the concept. The nth root of a number is the same as the number raised to the power 1 out of n. So let's look at if n is 2. That means we are talking about square root. The square root of a number, if we put the 2 here, we have 2 out of 1. So it's the same as the number raised to the power half, which is the opposite of square. So what are we going to get for the cube root of a? 3 is the same as 3 out of 1. So the inverse of 3 out of 1 will be 1 out of 3. So instead of writing the cube root of a, we can write a raised to the power 1 out of 3. And this is the concept for the nth root. So the nth root of any number is the same as the number raised to the power 1 out of n. If it's a square root, it's going to be half. If it's a cube root, it's going to be 1/3. 4th root, 1/4, and so on. So that is one of the concepts. Let's pick an example. Square root of 4. We are using indices to prove. Now, for most students, I know the square root of 4 is very easy for you. And what's the answer? The square root of 4 is 2. Now, we would like to use indices to solve this question. The square root of a number is the same as the number raised to the power. Square is 2, so it's going to be half. Now, this half, can we write 4 as a number raised to the power 2? Yes, we have 2 squared giving you 4. Then here we can apply our power law, just like we studied. So we are going to write only one of the bases and multiply the powers. Half times 2 is 1. Now we have 2 raised to the power 1, which is the first property that we talked about. Our final answer is 2. So it means somebody can definitely solve square root of 4 and get 2. And we can use indices, go through the whole step, and also arrive at 2. So that is the nth root. The next property is, what if the base is a fraction? Have you thought about it? Now let's look at what if the base is a fraction. A out of B or A on B, all raised to the power n. Remember, we are still sticking to the laws. All right? Now, if it's a fraction, it means we can decide to write the powers and then obey the laws. All right? Now, considering this power is supposed to come in and multiply the 2. So it means this n is supposed to come in and multiply the powers of the numbers in the bracket. Now let's bring the numbers in the powers of the numbers in the bracket. So A is the same as A index 1, B index 1. So we have 1 times n, B 1 times n. And what is 1 times n? We have n. Please make sure that the powers are written as superscript and not subscript. Okay, be very careful. Don't bring this n down. If it comes down, it means something totally different. So our final result, we are having A raised to the power n out of B raised to the power n. So what are we trying to imply? We are saying that if a fraction raised to the power a different number, what happens is that the power here would enter this bracket and multiply the powers, just as in the third law, which was the power law. Let's pick an example. Wow. So here we have A cubed or A raised to the power 3 all out of B raised to the power 3 and the whole thing raised to the power 1 out of 3. Now this power is out there alone and it would like to get inside. So when it comes inside, because it's a power, it's going to work with only the powers. So now let's look at what will happen. And remember that this one is coming from the third law that we talked about. And so we are going to multiply the powers. Then we can simplify. We are now left with A out of B. Very simple. Let's pick an example. This is the concept. Let's pick another example. Here we have A squared, B raised to the power 4, all out of C raised to the power 6, then everything raised to the power half. Remember, we are sticking with the concept. Now, this half is a power, and it's going to enter this bracket and it's going to work with individual powers, okay? So look at the powers of A. This A has a power of 2, the B has a power of 4, the C has a power of 6. So now let's go through what will happen. We have so it means the half is going to affect everybody. Every base with the power is going to meet this half. And that is the concept we are trying to put across. If you are lucky, the numerator is only one base with a power, you are good to go, as in the previous example. So now let's try and simplify this. 2 goes into 2, we have 1. 2 goes into 4, we have 2. 2 goes into 6, we have 3. So what's our final answer? We have A index 1, B index 2, and C index 3. A index 1 is A. So we can write AB squared all out of C cubed. Take your time. I would like to take you through again. I said this power is going to enter this bracket and is going to affect every power. If the power is not written, write it there so that you can see the effect. All right? So this A has 2. This half is a power is going to work with powers here. It's because it's outside the bracket. Remember, this is what we call the power law. Okay? You go through the same steps and then we are going to have our final answer here. Now, let's go through our last property for the day. And we pick 2 questions and then we solve them. With our last property, we have the fraction all right. This time, the power is negative. Does it really matter? Yes, it does. Why? Because we are saying that it is possible to have a question like this. Now let's look at how to go through. We are going to go through this work the same way we did the other one. First of all, if the numbers don't have powers, give them powers. Any number without a power is the same as the number raised to the power 1. Let this negative n enter the bracket and work with the powers. Good. Now let's follow up. 1 times negative n, negative n. Wow. Now we are left with a raised to the power negative n out of b raised to the power negative n. If you have done the work up to this stage, you've done pretty well. But please, you have to be a genius. You have to move on because maths, normally the questions, you have to work it to the latter, okay? Now, let's look at how to write this question in a different way and continue. All right, so we would like to continue from here. I've told you we have to move on. This answer is good, but it's not the best. So let's look at what we can do about this. Wow. Now, we have a raised to the power negative n divided by b raised to the power negative n. Today, we have a negative index. Wow. So negative index, I said, is going to be a fraction. And what is the numerator going to be? 1. And what is the denominator going to be? The same number this time, the power is going to be positive. Now we've come to our concept of fractions. Now there are fractions now. How do we divide 2 fractions? The first thing is maintain the first fraction. Change the sign to multiplication. Write the reciprocal or the inverse of the second fraction. Remember, we cannot divide them. So let's multiply the concept of fractions. Whenever you cannot divide, you multiply the numerators out of, you multiply the denominators. Wow. Now we've come to the end of our answer. The answer looks positive. Good. If you look at this question and the answer, you can see that the fraction has been written in the inverse form. And now this power has changed. So here we can write it this way. And that is the concept we would like to take you through. Now, instead of going through this long work, if you look at our final answer, what we could have done is that we swap the numerator and the denominator. That is, we write the inverse. And then we make sure that after swapping, we change the power. And this is a very nice concept. You can do the work this way. We are going to use this concept to solve one of our questions right now. Four out of 9, all raised to the power negative half. So what can we do? First, let's swap the fractions. And let's make the power positive, as in the concept. Now, we've gotten to the stage where we can apply the previous step we did in step 5 here. What do? We make sure the powers are clearly written here. And then the powers can now, this power here can now enter. We have remember, I've told you when we're learning the nth root that any number raised to the power half is the square root of the number. So what's the square root of 9? We have, and what's the square root of 4? We have 2. And this is our final answer. Now we've gone through the concept and some properties. We would like to take some 2 questions and then we are good to go. Remember to subscribe. If you like it, then please follow the link. All right, give me feedback and I would like to really help you out with any difficulty regarding indices. All right, so we have a very good question that is going to test us on some of the properties. Please don't be afraid or get frightened with the fractions. They are part of what we are supposed to learn. So we have to be serious and get it done. All right, so let's look at this. Are the bases the same? Yes, the bases are the same. Product law. So we can write one of the bases. and then add the powers. So here we have 1 out of 3 raised to the power 2 plus 1/3. 2 plus 1/3 is simply 2 raised to the power 1 out of 3. If you have half and you are given 1 and you are asked to add them, you are going to have 1 and half. So a whole number plus a fraction will be the whole number and the fraction written together. Now, let's look at this work, where we've got into. Here too, the bases are the same. The division law. We can write one of the base and then subtract the powers. Wow. So now we are really going to work the powers aside. That is, we are going to subtract two fractions here. One is a mixed fraction, the other is a proper fraction. So let's work that one aside. We first change this one to an improper fraction by multiplying this 3 by 2 plus 1 all over 3. So let's go through. 3, 2, 6 plus 1 all out of 3. Wow. And here, if you are really good with the concept of LCM, fine, you can do that. If you are not good with the LCM, multiply these 2 by both the numerator and denominator here. And multiply this 3 by both the numerator and denominator here. So here, the denominator here multiply these 2 figures. The 2 here multiply these 2 figures. Now we are going to have a common LCM, which is 6. So here, 7 times 2 is 14 out of 6. And these are like fractions. So we can always represent the denominator as 1 and then subtract the numerators. 14 minus 3 is 11. So when we bring our work here, so here our final answer, we have 1 out of 3 raised to the power 11 out of 6. And if you can solve this question up to this part, believe me, you have really come this far. You can really know that you are doing really well. Let's follow up to the second question, and then we move on. All right, so this is our last question for the day regarding indices. Now, this question we have simplified. 4 raised to the power -1 plus 4 raised to the power 0, all out of 2 raised to the power 2, all raised to the power 2 times 2. So we are going to take our time and work. Now, what does 4 raised to the power -1 means? I said anytime you have a negative index or a negative power, we are going to have a fraction. What will be the numerator of that fraction? Always 1. Out of the whole thing, this time make sure the power is positive. So here we have 1 out of 4. And then we have 4 raised to the power 0. Any natural number raised to the power 0 means the number is being divided by itself. So what is 4 divided by 4? It's 1. So 4 raised to the power 0 would be 1. Let's go to the denominators. Let's apply the product law here. Okay, so obviously 1 plus 1 out of 4, I just said, if you have a whole number plus a fraction, we are going to have the whole number with the fraction written together. If you have 1 and then you are given another half, you have 1 and half. So 1 plus 1 out of 4 would be 1 whole number, 1 out of 4. Wow. Down there, we are supposed to apply the product law. This power is not showing. A number is the same as the number raised to the power 1. So here we have 1 whole number, 1 out of 4, all out of 2 raised to the power 5. We've applied the product law here. Let's try and change this 1 and do a proper division here. 4 times 1 plus 1, we are having 5 over 4 divided by 2 raised to the power 5. 2 raised to the power 5 means 2 is going to multiply itself 5 times. So let's go through. 2, 2, 4, 4, 2, 8, 8, 2, 16, 16 times 2 is 32. So here we have, and remember, I said that if you want to divide 2 fractions, maintain the first fraction, change the division sign to multiplication, write the inverse of the second fraction. Let's see if we can simplify and reduce this. All right, so for those who are very good with fractions, this is where you really have to show your prowess. Okay, now let's look at it. We cannot divide any numerator by any of the denominators. What do? Fractions. If it's not working, multiply both numerators and then multiply the denominators. 5 times 1, we have 5 here. 4 times 32, let's take our time and multiply. 4, 2, we have 8. 4, 3, we have 12. So our final answer, we have 5 out of 128. I think we've come this far. Thank you. If you really enjoyed the video, make sure you subscribe. We are in a coronavirus era, and please be very careful. Use hand sanitizers. Get a very good hand sanitizer anytime you really go out and then you have to touch door knobs and all that. Please make sure you are really staying safe. Make sure this is the right time to study. You have to subscribe to this channel. I'll be sending you posts on other topics that I think students are really finding difficulty. For those in SS, I'm really going to have my subsequent video where I'm going to take you deeper into this indices topic. Thank you for staying with me, and it's time to go. See you next week. Bye.